Internet of Things has opened up a lot of possibilities for a lot of modern day conveniences. And one such convenience is the flexibility that connected healthcare devices offer. Connected healthcare devices allow information about a patient's health status, auto monitor patient's movements, and alert the doctors or families. In our case, we'll be looking at one such device that tracks the consumption of tablets by the patient. When a patient opens a blister pack, the system tracks the consumption and alerts the people registered on the system through the use of Wi-Fi or cellular data. The key components of the connected healthcare devices are Bluetooth Low Energy Module, also known as Bluetooth LTE, microcontroller, and a flexible smart blister layer or FSBL. To make the components work, each component needs to be programmed in a certain way that they are able to communicate with each other and also work effectively. Components would require an extensive time frame to program and go through rigorous testing process to achieve maximum efficiency. Since we've already perfected this time-consuming process, we made a readily available turnkey solution known as a recipe. A recipe is a complete element which has all the necessary programming to make things work faster. There are two forms of recipes, hardware and software, which are readily available for you to download. The recipes we used for hardware are sending data via Bluetooth, optimizing Bluetooth Low Energy, configuring Bluetooth Low Energy Master Slave, using CPU to store data, electronic essentials for generic PCB, setting up storage, setting up RTC, setting up microcontroller, programming the ROM, toggle logic between GSM and Wi-Fi, setting up and optimizing a communication antenna, setting up a power switch, connecting GSM module to the cloud, connecting SIM 7100 module to the cloud using MQTT, optimizing power source, that is battery. The software recipes we used are turnkey location-based search integration via Google Maps, setting up Bluetooth connectivity between Android and IoT device, any device registration on Bluemix, establishing MQTT between any iOS device to Bluemix, establishing MQTT between any Android device to Bluemix. With the necessary software and hardware recipes and the connected healthcare device, we're ready to configure and set up the device to work efficiently.
Right, so these are the components of the system. This is the main communicator board. This is the FSBL board. This is the battery for the communicator. The battery for the FSBL are on the board itself. This is the same FSBL board with a protective covering on top. And so this is the communicator board. The main microcontroller is this. This is the GSM module, the 4G GSM module. This is the Bluetooth module. This is the Wi-Fi module. This is the slot for the SIM card. The SIM card goes in here. This is the power switch. And here there are a bunch of LEDs. And then at the back there is a connector. Okay, so this is the connector for the battery. The battery connects into the connector that way. So that is the communicator board. Then you have the FSBL board. On the FSBL board, again the main microcontroller, the batteries, the Bluetooth BLE module, and this little switch here is the power switch for enabling the blister when it is ready. And this connector is the edge connector where the blister sheet is connected. This is a similar FSBL, but this time it is with a protective coating on top. So the same thing, does the same function, just with a protective covering on top. Again, the blister connector to which the blister sheet will be connected. So in terms of preparing the blister sheet, there are three components to it. One is the blister tray, where the medications will be filled in these slots. Then you have the trace sheet. The trace sheet contains conductive traces that are printed using silver ink. So these are conductive traces that will detect the rupture of any of these blister slots. And then finally you have the color coded sheet, where the prescription with the date information and on top the patient information is printed. And when the blister sheet is prepared, so on the slot, first you have the blister tray, then the conductive sheet, and then the color coded prescription sheet. So these three stick one on top of each other, and finally this whole sandwich is taken and the blister connector is connected here. So that completes the whole blister sheet. So that is the whole assembly. Stop it. Adyan. On it. Right, so when we power on the communicator, initially all the 4 LEDs go on once, then the power LED, this LED, this remains constantly on. So the first LED, power LED goes on. Then you have this LED, this is for GSM status. And this LED, the third LED here, this one is right now blinking. It is looking for a Wi-Fi hotspot to connect to. So right now the hotspot is turned off, so it is not connecting. Once we turn on the hotspot, it will connect to the Wi-Fi hotspot.
Checking for GSM.
And while the Wi-Fi is not available, it was checking for GSM. This LED is for GSM. So now it has gone back to Wi-Fi. It is now looking for the Wi-Fi hotspot. The moment it finds a Wi-Fi hotspot, it will go constantly on. Instead of blinking, it will go on constantly on. Right. So now it is going constantly, so it has found a Wi-Fi hotspot to connect to. It is connected to the Wi-Fi hotspot at this point in time. And once this is connected, it is blister. Now once this is connected, this is ready to communicate with the cloud. So once the blister is brought home and it is turned on, you will see the power indicator on the blister goes on. So now that the blister is enabled, the blister will connect to the communicator board. And this LED here is an indication of that. This is an indication that over Bluetooth connection, the blister and the communicator are paired. Now it is already connected to the Wi-Fi. So any rupture event, any blister traces that are torn will be registered on the cloud automatically. The Wi-Fi, turn off the Wi-Fi. So now we have turned off the Wi-Fi hotspot. So after a little while, this LED will go off and this will jump over to the GSM. Correct. So the Wi-Fi connectivity is lost. Now it is looking for connectivity over GSM, the 4G connectivity. So once it has found the 4G connectivity over the GSM, this LED goes constantly on. Now it has jumped from Wi-Fi to GSM connectivity. So if the Wi-Fi is turned on again, this will go off from the GSM back to the Wi-Fi. So Wi-Fi gets the first preference, GSM gets second preference. So whenever Wi-Fi is available, it will come back to Wi-Fi. So now once any of these traces are torn, the blister DLE device here, the edge connector here, this will transmit the information to the communicator, from the communicator all the way to the cloud. For example, when I tear a particular trace, like that, this event will be registered on the cloud automatically.